Welcome to qnawire.
Alright, so we're being asked to show that the curve y equals 1 plus x over 1 plus x squared has 3 inflection points and they lie on one straight line. So, to first of all find the inflection point, we have to find the second derivative. So, so I found the first derivative. I'm doing this so that you can see if you're on the right track. So the first derivative comes out to be 1 minus x squared minus 2x all over 1 plus x squared. And then this whole thing is squared. And then the second derivative, there are variations to this answer. I'm going to show the different forms. So you can get 2x cubed plus 6x squared minus 6x minus 2, 1 plus x plus, 1 plus x squared, and then this whole thing is cubed. And then you can actually simplify this further by pulling out a factor of 2, and then 2 times x squared plus 3x squared minus 3x minus 1, and then 1 plus x squared, and this whole thing is cubed. And then you can factor this by grouping, or you can you can factor this by grouping, and or you could just, simplify it, and then what you get eventually is 2 times x minus 1, and then times x squared plus 4x plus 1 is equal to 0, all over 1 plus x squared, and this whole thing is cubed. And we're looking for where this entire thing is equal to 0, because that's where inflection point occurs. So we know that the first point will be x equals 1, because if you plug in 1, you get 0. And then the second one is this polynomial right here. And yes, you have to use the quadratic formula, because there's no a nice and whole number factor. So we're going to go ahead and do that on the other side. So when you apply the quadratic formula, you get negative 4 plus or minus the square root of b squared, which is again 4 squared, and then minus 4ac, which is going to be times 1, and then times 1 again, over 2a, but a is 1, so 2. And then some more simplification eventually leads down to negative 2 plus or minus root 3. And if you plug these in a calculator, you get negative 3.73 approximately, and negative 0.268 respectively. So now that we know our 3 points where the second derivative is equal to 0, we can now evaluate for where sign changes occurs for f double prime, and see where exactly the inflection points are. So this is going to be negative 3.73, negative 0.268, and then there's going to be 1. So if you plug in values less than negative 3.73, you get negative. Between these two numbers, you get positive, negative, and positive. So we have inflection point occurring at negative 3.73, negative 0.268, and 1, because that's where it's going from negative to positive here, and then positive to negative, and negative to positive. So we proved that there are 3 inflection points, but now we have to prove that they all lie on the same line. So that means they have the same slope. So the way to do that, well, first of all, we got to find the values at these points, like just on the function. So f of 1 is equal to 1, and then f of root 3 minus 2, well, that's equal to root 3 plus 1 over 4, and then f of root 3 plus 2, well, that's equal to negative root 3 plus 1 over 4. So now we have the point. We can just apply the formula for a slope. M equals y2 minus y1 over x2 minus x1. So we can evaluate it between first from root 3 minus 2 to 1. So between these two and then between these two. And if the slope are the same, then we've proven that they lie on the same line. So we do root 3 plus 1 over 4 minus 1 all over root 3 minus 2 minus 1, and this gives us 1/4. And then for the next one, we do negative root 3 plus 1 over 4 minus negative root 3 plus 1 over 4. And this is going to be negative root 3 minus 2 minus root 3 plus 2. And this also comes out to 1/4. And so that's how you know, that's how we prove that the inflection point lie on the same line.